Okay, there was all kinds of special things going on in this test that we had this week. The first two questions themselves were answered pretty well. The biggest mistake was just remembering what the stereochemistry of the products were. Obviously, this is a lithium aluminium hydride reduction of the ketone. So you're going to get the alcohol, and the important thing is that the alcohol itself, the nucleophile is H minus, it's very small, it wants to be axial, so the OH ends up being equatorial. This itself is going to want to be the locking group, the isopropyl group, so it's going to want to lock equatorial, so that means that the OH is going to be pointing up because the H that went in, that over there is axial. All right, axial down. Over here we have the cis-fused 5-5 rings, and because of the shape of that, the hydrogens are pointing towards the back, which means that this whole thing has like a cup shape pointing up towards us. All right, and the most accessible side is the bottom side of this ketone over there. So the nucleophile, the phenyl group, is going to add from the bottom, and so we're going to get H, and the it'll push the OH up. That'll be formed. Okay, so with that. Okay, easy enough. But this question, all right, so this was a whole lot of special answers that we're going over here. The first part of the question said you need to explain the regioselectivity of the enolate formation. And that is, in a very simplistic sense, and that's all I wanted you to say, was just that it's the kinetic enolate. You can form the enolate there or there. All right. So for 1 mark, I needed you to say something about it being the kinetic enolate. In an exam or test, I'd expect you to say a little bit more because bulky base and low temperature. Now, one of you actually picked up on something else which is important, which I myself have completely missed, and that is that in order for the enolate to form, the proton that must be taken away needs to be in the axial position. And this is going to be the locking group on the 6-membered ring. So this is equatorial. That means that this proton over here, this methyl group over here is actually axial. It's axial up. That means the proton here is actually equatorial down. So to remove this proton is actually quite difficult. The whole molecule would have to ring flip so that this went into an axial position. Then this would be axial, and it could form the enolate on this side. So actually, we could have probably got away with not having a very big bulky base like that. So well done to Paula Lowe, who was the only person who picked up on that, and it was really quite an impressive thing to have noticed. The rest of the question has to do with the cyclohexene half chair. So when we form the enolate over here, we're going to be left with one of 2 half chairs. The one will look like that. There's O minus, and the other one is going to look like this. O minus. Put the methyl group there, and this big aryl group is facing down. Okay, so we just write AR for this. And in this position, it's AR, it's axial down. There's this methyl group over there. So this one is the preferred one, and you would have got a mark for that. And then you have to decide whether the electrophile comes in from the top or from the bottom. Notice here, and a lot of the number of people who kept on talking about the benzyl bromide being the nucleophile. It's not the nucleophile, it's the electrophile. The enolate is the nucleophile in the reaction. And so from the top position, we're going to get the twist chair, and from the bottom we're going to get the twist boat. So it's just a good idea to draw these out. So that's A and B, and I said you could turn over the page and use the other side. So the twist chair is going to look like, wherever I want to draw it, I actually need to see it over here, so I'm just going to try and draw it over here. As this lifts up, it's going to go like that. I'm going to got the other stuff behind. So, okay. Okay, this is the bond that's in the front there that's twisting. This is the one that's going to the back there. Okay, and so we've got our aromatic there still. This is where the nucleophile is, or sorry, the nucleophile is attacking to get to the electrophile. The benzyl is formed there, and this is becoming the O like that, and we've got a methyl group pointed over there. So this is twist chair. If you drew it out, you got a mark, all right, but you've got a mark for also saying that twist chair is the preferred one. And then the other option is the twist boat, where it goes down like that. So this front bond is at 90 degrees to it. So, okay. So that's the big bond there. All right, so we get the aryl. This becomes benzyl group went to the bottom. Methyl group is still somewhere over there. And so this then is twist boat, and which is disfavored. Okay, so drawing it would have given a mark, and the fact that you said that it's disfavored would also have got the mark. So that's why it comes in from the top. So we've been 5 marks plus the kinetic. That's your 6 marks over there. All right, that's all that was needed for that question.